Welcome. In today's video, we're going to look at June 2023 Cameroon GCE Advanced Level Maths with Statistics, Paper 1, and we'll be focusing on Section B, which deals with statistics. Okay, here we are in Section B, which is the statistics section, and it consists of 15 out of the 50 MCQ questions in the whole paper. In the first question of that section, we have that the median of the set of data, and we have numbers listed here, and they want us to find the median. In order to find the median of a set of data that is given discretely, we start by arranging the set of data in increasing order. So I have 3, 3, 3. So 3 appears 3 times. I write 3, 3, 3. Then I have 4, 4, 4, and 4. So 4 appears 4 times. 4, 4, 4, 4. The next number in the series after 4 is 6. It appears once. Then we have 7. 1, 2. It appears twice. Then we have 8. We have 1, 2, 3. 8 appears thrice. And then we have 9. 1, 2, 3. 9 also appears thrice. 9, 9, 9. So at the end, we look at the number or numbers that appear in the middle of the data set, and that will correspond to the median. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers in the data set. And so for you to have the middle numbers, since 16 is an even number, it means I have 16 minus 2, which gives 14. All over 2 would give 7. So there are 7 numbers on either side of the 2 numbers that are in the middle. So I count 7 from the left. I'll get 1, 2, 3, 4, 5, 6, 7. And so the middle numbers are 6 and 7. So median would be their average. So 6 plus 7 divided by 2, which gives 6.5. And so the correct option is C. In the second question, we have that 2 independent events, A and B, are such that P of A equals 0.3 and P of A union B equals 0.58. P of B equals... So here we have P of A union B. Using the compound event formula, it's supposed to be P of A plus P of B minus P of A intersection B. And since A and B are independent, P of A intersection B will be the product of the two probabilities. So P of A times P of B. And P of A union B is given as 0.58. That should be equal to P of A, which is 0.3, plus P of B, we call it X, what we're looking for, minus P of A, 0.3 times P of B, which is X. And from here we have 0.58 minus 0.3 equals 0.7x. X minus 0.3x gives 0.7x. And we have that 0.28 equals 0.7x. So that x equals 0.28 all over 0.7, which gives 0.4. So the correct option is A, 0.40. Okay, in the next question we have the data set of ordered pairs xy 4, 8, 5, 9, 6, 6, 7, 3 is such that x bar equals 5.50 and y bar equals 6.50. The covariance of the ordered pairs is, and we have these options. Covariance of x and y is given by summation xy all over n, the sample size, minus x bar times y bar. And from the information given, we already have x bar and y bar. So what we need to find is summation xy, and the other pairs have been given as well. For the other pairs, their products are 32, 4 times 8, 45, 5 times 9, 36, 6 times 6, and 21, 7 times 3. So the sum of those other pairs is what we're going to write there, and that sum corresponds to, it gives 134. And so our covariance would be 134 all over n, and we have 4 other pairs, so n is 4 minus x bar. X bar is given as 5.5 into y bar, which is given as 6.5. When you do all the calculation, negative 2.25 corresponding to option D. In the next question, we have that a random variable x has cumulative distribution function f of x equals k into 3x minus 1 for x equals 1, 2, 3. The value of the real constant k is, and we have these options. So in this question, we have been given the cumulative distribution function. And for the cumulative distribution function, f of 3 should be equal to 1. So the sum of the probabilities from 1 to 3 should be equal to 1. That is the characteristic of any random variable. And so the sum of all the probabilities up to 3, because f of 3 actually means the sum of all the probabilities up to 3 should be equal to 1. And f of 3, we can simply substitute 3 in the cumulative function, which will give k into 3 into 3 minus 1 equals 1. That gives 8k equals 1. So that k equals 1 all over 8. And the correct option is C. In the next question, we have random variable x follows binomial distribution with parameters n and p. E of x equals 2, and this part surely has to do with var x. The variance of x equals 1.6. The value of n is, and we have these options. So if the missing part there should be var x, which I suspect, then this is the question. In order to solve, I would have to use the information given. We have that the mean of x is 2, and normally the mean of the binomial distribution is NP, so NP equals 2. We also have that var x, the variance of the distribution, is 1.6, and the variance of the binomial distribution is NP cure, that corresponds to 1.6. From there, since NP is 2, we have that 2 cure replacing NP by 2. We have that 2 cure equals 1.6, so that cure would be 1.6 all over 2. So cure is 0.8, so that P now should be 0.2, since P and cure always sum up to give 1. And so we are looking for N. We have that NP equals 2, the mean was given as 2, and since we know P already, 0.2 N equals 2 follows that N equals 2 over 0.2, which is 10, and so the correct option is D. In the next question, we have a frequency distribution is such that the lower quartile equals 22.5, the median equals 24.3, and the upper quartile equals 28.7. The quartile deviation of the distribution is, and we have these options. Normally, the quartile deviation of a distribution is the semi-interquartile range. So, quartile deviation equals upper quartile minus lower quartile divided by 2. So, we get 28.7 minus 22.5 all over 2, and that gives 6.2 over 2, which is 3.1, and we have option A as the answer. In the next question, we have a sample of size 30 is drawn from an infinite population with mean mu and variance sigma squared. The variance of the sample mean is, in the case of a sample drawn from an infinite population, the variance of the sample mean is given simply as s squared equals sigma squared. That means the variance of the population over the sample size. Here we have sigma squared over the sample size being 30, and so we have option D as the answer. In the next question, we have a sample of size 8 drawn from the population gives rise to summation x equals 391, summation x squared equals 19,159. Using this sample, the unbiased estimate of the population variance is, and the question was faulty, no alternatives were given. However, the unbiased estimate of the population variance simply means the best estimate of the population variance from the sample given, and the formula is s squared equals n all over n minus 1 times the sample variance. So already we have n all over n minus 1 into summation x squared over n minus x bar squared. So x bar squared. So all the data has the information we need. N equals 8, because the sample size is 8. Summation x squared over n is equal to 19,159 over 8, while x bar is summation x over n, which we have it as 391 all over 8. And if you substitute all these values, you will get the best estimator or the unbiased estimator of the population variance as per the information given. In the next question, we have a population has mean 15 and standard deviation 2.3. A random variable of size 81 is taken from the population and its mean is found to be 15.4. A hypothesis test is to be conducted to verify if the mean has changed. The value of the test statistic for this test is, and we have these options. Normally, if we are doing a Z test, then the test statistic should be the Z value, which is given by x bar, the sample mean, minus the population mean, all over the square root of the population variance all over n. And we have x bar, the sample mean, as 15.4 minus the population mean, which is 15, divided by the square root of the variance, which is 2.3 squared, divided by the sample size, which is 81. When you evaluate all that, you get 1.565 as the test statistic for that hypothesis test. In the next question, we have 10 pairs of values or other pairs x, y, which are such that x bar equals 13, y bar equals 7.08, the variance of x equals 1.246, the variance of y equals 1.611, and the covariance of xy equals 1.389. The product moment correlation coefficient is, and we have these options. Normally, the product moment correlation coefficient is given by R equals the covariance of xy all over the standard deviation of x times the standard deviation of y. So we have covariance given in the question as 1.389 all over the standard deviation of x, which corresponds to the square root of its variance, 1.246 times the standard deviation of y, corresponding to the square root of its variance, 1.611. And when you simplify or evaluate that, you have the product moment correlation coefficient as 0.98, corresponding to option A. In the next question, we have a continuous random variable x has probability density function f given by f of x equals 3 all over 16 x into 4 minus x for 2 less than equal x less than equal 4. The mode of x is, and we have these options. So in the case of a continuous random variable, the mode corresponds to the value of x for which f of x is maximum. So to find that value, we'll rely on calculus methods. F of x is supposed to be 3 over 16 into 4x minus x squared. In order to get the value of x for which f of x is maximum, I find f prime of x, which corresponds to 3 all over 16. Differentiating the bracket there, I have 4 minus 2x, and f of x will be maximum where f prime of x equals 0. So we get 4 minus 2x equals 0, giving x as 2. Now, to confirm that x equals 2 is the value of x where f of x is maximum, we find f prime prime of x, the second derivative, which should give 3 over 10 into negative 2, and it shows that it is less than 0. Hence, x equals 2 is the value of x at the maximum turning point. And so the mode of the distribution is x equals 2, which corresponds to option D. In the next question, we have a continuous random variable x has probability density function g given by g of x equals ax into 2 minus x for 0 less than equal x less than equal 2. The value of the constant a is, and we have these options. Generally, for a random variable, the sum of all its probabilities must be equal to 1. And so we have that integral from 0 to 2 of g of x, ax into 2 minus x, the x should be equal to 1. So the sum of all the probabilities of the real values from 0 to 2 of g of x must be equal to 1, as the definition of any random variable specifies. So we have a into 2x integrated gives x squared, minus x squared integrated gives x cubed all over 3. From 0 to 2 equals 1. So that we have a into 2 squared, which is 4, minus 2 cubed, which is 8 over 3, equals 1. A into multiplying through by 3, we have 12 minus 8 equals 3. So 4a equals 3, follows that a equals 3 all over 4, corresponding to option B. In the next question, we have a random variable x follows Poisson distribution with parameter lambda. If 49 p of x equals 0 equals 8 p of x equals 2, the value of the parameter lambda is, and we have these options. Now, in the case of a Poisson distribution, we have that p of x equals x, probability mass function being e to the negative lambda, lambda to the x all over x factorial. So 49 p of x equals 0, we then have e to the negative lambda, lambda to the 0 over 0 factorial, equals 8 p of x equals 2. So we have e to the negative lambda, lambda squared over 2 factorial. And e to the 0 is 1, 0 factorial is 1, while e to the negative lambda cancels on both sides. We have that 49 equals 2 factorial is 2, it cancels 8 to give 4, so 4 lambda squared, so that lambda squared equals 49 all over 4, lambda equals 7 over 2 when you find the square root of 49 over 4. So lambda is 7 over 2, which corresponds to 3.5. So option B is the correct option. In the next question, we have for two events a and b, p of a equals 1 over 5, p of b equals 3 over 5, p of b given a equals 1 over 10. The value of p of a intersection b is, and we have these options. So actually, to find p of a intersection b, we have to make use of the available information. P of b given a is related to p of a intersection b. Actually, p of b given a equals p of b intersection a all over p of a, so that p of b intersection a equals p of b given a times p of a, and p of b intersection a is the same as p of a intersection b, which gives p of b given a, given in the equation, as 1 over 10 into p of a, which is 1 over 5, and that gives 1 all over 50, corresponding to option B. In the last question, we have that a discrete random variable x follows the binomial distribution with parameters 100 and 0.2. Using the normal approximation, p of x greater than 30 is equivalent to, and we have these options. You have to note here that in order to estimate a discrete random variable using the normal approximation, there is the need to do a continuity correction. First of all, we start with the available information. We need the mean of the distribution. For the binomial distribution, the mean is np, and this corresponds to 100 into 0.2, which gives 20. We also need sigma, the standard deviation, which is the square root of np cure, and that corresponds to 100 into 0.2 into cure, which is 1 minus p, so cure should be 0.8, and the square root of that, we have 100 times 0.2, 20 times 0.8 should be 16, and the square root of 16 gives 4 as the standard deviation. Now we have to start finding p of x greater than 30 by doing a continuity correction, as I earlier mentioned. This is because we are moving from a discrete random variable to estimating its probability using the normal approximation. And for you to use the normal approximation, it means you would calculate your probability value using the area enclosed by the normal curve, which is a continuous curve. So there is a need that we do a continuity correction to fit the continuity that is being employed by the normal distribution in getting the probability by area. So in order to do this continuity correction, we have to start by looking at the real boundaries. X greater than 30 actually starts with integral values of x from 31 moving up to infinity. So we have the lower bound of the real interval being 31, and to do the continuity correction we subtract 0.5 from that lower bound. So actually we are dealing with p of x greater than 30.5 when you subtract 0.5 from the real lower bound 31. In the next step, we standardize our value into a z-score. So we have p of z greater than 30.5 minus the mean. The mean of the distribution is 20 divided by the standard deviation, which is 4. When you evaluate all that, you have p of z greater than 2.625. And looking at the options, we don't have that solution. However, if you do the calculation without continuity correction, you would have D as the correct option. Thanks for watching, and before we conclude, please, it is important to note that the statistics paper relies very much on formulae. You can see that throughout this exercise we have used a lot of formulae, and luckily for you, all those formulae are in the formula booklet. So anytime you need the formulae, you would have to go to the formula booklet to use them. The next important thing is that the examiner uses a lot of detractors in the question. That means most of the time the data that are included in the question will not actually be used in the calculation, so you have to be careful in that aspect too. If you are new to the channel, please consider subscribing and activating the notification bell so that anytime we upload a video, you would get it handy. Also, like and comment on our videos, and if you also have suggestions as to what topics we should treat, you comment in the comment section to alert us about that. Please support us very much by sharing these videos to your classmates and as well as friends, so that they get to know more about the channel, which has a lot of resources for your GCE examinations. We wish you good luck as you are looking forward to writing your GCE exams in May.